So see, today we'll be studying current electricity. So is this chapter done for you in college? Okay. So current electricity. So yeah, in previous chapter and all, previous two chapters, electric charges and field and electric potential and capacitance. Here, what we studied was the charges were at rest, correct? They were not moving. But now in this chapter, we are studying the case of charges such that those charges are moving. Okay, those are not still. Yeah. So now, see the word current and electricity. So let's try to understand it. So what is current? So current is flow of charges. It's the flow of charges. And see electricity. So what do you mean by electricity? So is current and electricity both are same? No, those are different, right? So now see electricity means it is form of energy produced by electrons, produced by electrons. See here, when I said current, it is flow of charges. I have not mentioned anything about electron. But when are we talking about specifically about electricity, it is due to electron. Okay, so that is the difference. So see, there are some characteristics of this electricity. Correct. So in electricity, when we talk about electricity, we talk about current, we talk about voltage, okay, and we discuss about resistance. These all are different characteristics of electricity. Okay, and see in electricity
Yeah.
there are two types. Okay, and these are familiar to you. Okay, one is called static electricity. So in your first chapter you have studied, right, static electricity. And see the second type is current electricity. That's what we are going to study right now.
Okay.
Okay, so see generally what is current? It is flow of charges, correct? But in physics, how we define what is current? So in physics, current is rate of flow of charges, flow of charges, charges. Okay, and see this word rate, that is important because see if I, so what rate I am speaking, so what speed I like, in what speed I am speaking, that matters, correct? If I am doing this class, okay, what speed I am talking or speaking to, it is important because if I say like this, rate of flow of charges, see I have given too much of gap, correct? And it is not a meaningful sentence, correct? And if I speak fastly, okay, rate of the flow of charges, even you can't understand it. Even that also doesn't count for a meaningful sentence, correct? So see at what rate the charges flow, that is significant. Okay, so that's why current is rate of flow of charges. It's not just flow of charges, it is rate of flow. Okay,
Okay.
yeah. So now see why we have to study this topic, because in our daily life we come across some devices, okay, and those devices operate at in operate on the current, correct? And this current is supplied in controlled manner, correct? So see, if the current is not supplied in the controlled manner, what can happen? The devices can be damaged, correct? So if you have TV,
Yes.
so in TV also the current is flowing in constant controlled manner. Okay, in your mobile, so in your mobile also there is a battery, correct, and that battery supplies the current in the controlled manner, correct. And see, here the battery in this chapter the battery has very important role. Okay, so now we know what is current. Current is rate of flow of charges. So how can I write the formula of it? So current, I denotes current. Okay, I is equal to q by t. Okay, how many charges are flowing per unit
Per
time. Okay, and SI unit for this is ampere. Okay, and it is denoted by capital A. Okay, so you say 2 ampere or 5 ampere or 2 milliampere. Okay, so usually you denote with capital A. Okay, it's the unit of current.
okay.
So see, this is just a formula for current. Okay, now see, in your first PUC and all, you have studied average speed, average velocity. In the same way, there is something called as average current. Okay, and see, if
Mm.
you consider a interval of time t2, t1 and t2. Okay, so in this interval of time, how many charges how many charges are flowing? Okay, so that rate is given by average current. So average current's formula will be delta q by delta t. So delta t is change in time, this is change in charge. Okay, rate of change of charges. Now see how we study average of things, correct? Average velocity, average current, average acceleration. In the same way, we study instantaneous. Okay, so we are
Mm.
particularly interested about at that instant what is happening, correct. So see, if I want to find out at t equal to 5 second what is my current, I is equal to how much. So in this time what I have to calculate is, it's not a current, it's the instantaneous current. So see,
Yeah.
instantaneous current is calculated in this way. So I is equal to limit delta t tends to 0, delta I delta q by delta t. Okay, now see, delta t tends to 0. So what do I mean by delta t tends to 0 is, see, I have many interval of time, correct. So 1
Mm.
second, 2 second, 3 second, 4 second. So if I want this interval, okay, so what I have to do is, this gap I have is there, right, delta t, I have to reduce it. So I am reducing the gap in such a way that it almost tends to 0, there is no gap at all. Okay, delta t tends to 0. So at that time what happens, you can find of that interval at that second or at that particular time what is the current, correct. So see, this is the
Mm.
definition of it. So see, in your mathematics you have studied, so if you have the condition in this way, you can, instead of writing this, you can write in terms of differentiation, correct, dq by dt. So did you understand this? How did I write this term?
Yeah.
Okay.
Kind of.
Yeah, so this is not much important right now. Okay, so even if you don't understand this, there will be no loss on continuity. You can understand the whole chapter. No, you'll understand it better later when you solve the numericals. Okay, so just don't worry about it. Yeah, so now see, current, my, what is the direction of current? Direction. So in what direction does the current flows? So see, we know what is current, it is flow of charges, correct. So now
Yeah.
the current, in what direction it flows? Can it flow randomly? No, it has some direction,
No.
correct. So see, initially what was assumed was, see, current was due to current was due to positive charge. Okay, so initially what was thought was current. What is current is there, no? This positive charge produces the current. Okay, and see how does positive charge flow? It wants to flow to, see, positive to negative, correct? So if you have a
Yeah.
positive charge, it has to flow from positive to negative. It attracts us to negative side, correct? So
Hmm.
how is the positive charge moving? It is moving from positive terminal to negative terminal, correct? So that's why what did the scientists do is they thought of, they said the current's direction is from positive to negative. Okay, this was
Hmm.
what scientists thought and they said this. Okay, later what happened, the electron was discovered. Electron was discovered. Okay, so now see, now the same scientist who told positive charge is responsible for current. Okay, now see, whatever they said about this is wrong, correct? So see, in metals
Hmm.
and all, what happens is there are free electrons. Okay, electrons are free to move within the metal, and these electrons are responsible for the this current. Okay, so now which is right? This is right or this is right? It is a direction of flow of current. So electron will travel from negative terminal to positive terminal. It will try to attract to positive terminal, right?
Hmm.
Correct. So see, there's a paradox now. So which is correct? Initially, what scientists thought that was correct, or this is correct? The second one is correct, right?
Yeah.
But see, what happened was the scientists, they didn't want to change the theory. Okay, they wanted to stick themselves for current direction. Current will flow from positive to negative terminal. Okay, they wanted to stick with this assumption only. Okay, that's why what they said was, okay, they did some modification. Okay, so just assume like this. So if this is my piece of metal, okay, and this is my positive terminal and this is my negative terminal. Yeah, so see, electron will move in this direction, correct? Negative to positive. And what they
Hmm.
before they said was this is the flow of current, correct? So see, the scientist named like this. Okay, this is the direction of current flow. Okay, this is the direction of current flow, and that direction is called electronic current.
Okay.
Okay, electronic current. No, no, it's not electronic current. Okay, so see, this, whatever this direction is, right? This is called electronic current. Okay, sorry, this is called electronic current. So why electronic current? Because this current is responsible due to electron. And see, this direction, what they have said, right? This is called conventional current.
Okay.
Okay, so see, in whatever circuits you see, the direction of current, they always give from positive to negative. Okay, so if somebody asks you what is the direction of current, you always have to tell positive to negative, and the direction of current is always opposite to the flow of electron. Okay, direction of flow of electron.
Okay. Yeah. Yeah.
So did you understand this concept?
Yes.
Okay, so now my question is current a scalar or a vector?
Um, it'll be a vector because the direction of flow of current depends.
So see, so you are telling it is a vector, correct? So why,
Hmm.
what is a vector? Vector is a quantity which has magnitude
Magnitude and direction.
and direction, correct? And direction. Okay, so does current have a magnitude? Yes, it has, correct. And
Hmm.
does it has a direction? Yes, but still you cannot say current as a vector. Okay, so current is not a vector, because see, for if some quantity is a vector, then it should obey vector law of addition. So see, what do I mean is, I don't say that direction is not important. Even direction is also important. Okay, so it has direction. There is no denying in it. Okay, but see, what happens with current is, you cannot say it is as a vector. Okay, it doesn't obey the vector law of addition. So for example, if I tell you, if this is 2 amps of current flowing in this direction, this is 3 amps of current flowing in this direction. Okay, so what is the total current? It is 2 plus 3, correct? 5
Yeah.
amp. So see,
Hmm.
if this was some other vector quantity, what would you do? You would apply vector law of addition, right? Triangular law of vector addition or parallelogram law of vector addition. You would do in that way, correct? But in
Hmm.
this case, you didn't apply any. You added just like a scalar, correct? So here, so but see, even though if you added like a scalar, okay, so what, it depends on the direction also. Now see, if this is 2 amperes of current in this direction, if this is 3 amperes of current in this direction, so what is the total current? It is 1 amp, right? 3
Yeah,
amperes
3
minus
minus.
2, correct? So you subtracted like a normal scalar quantity, but see, the direction matters, right? So here the both were in the same direction, that's why you added. Now one is in the forward direction, one is in the backward direction, that's why you subtracted. Okay, so see, current is actually a tensor quantity. Okay, so tensor, you will study it in your higher class. Okay, this is not required for you right now. So at your level, what you can say is, since it is not obeying the vector law of addition, it is a scalar quantity. Okay,
Okay.
yeah, so you understood this, right?
Yeah.
Okay, now see, who, now one question arises, who carries the current? Okay, what is responsible for current? How does current flow? Through what it flows, correct? So see, you know,
Hmm.
at, correct, so charge which are free to move, those charges carry the current, correct? The free charges, okay, the free charges are responsible for the current, correct? So now what is free charges, how, where we can observe the free charges? Okay, so you know atom, right? In an atom,
Yeah.
at the center there will be nucleus, correct? And there will be some orbits, correct? So now see, there will be some electrons in that orbits, correct? Orbiting. So
Hmm.
there will be some electron, okay, these whatever are inside, those are called bound electron. Bound electron, so what do I mean by bound electron is, those electrons are not free to move, okay, those are restricted. But see,
Okay.
now in the outermost shell, you'll have something called as valence electron. Okay, so valence electron are such kind of electron, if you have sufficient energy, those are free to move. Okay, so these
Yeah.
can, these are free to move, but what is the condition? Those are free to move but within the material.
Okay.
Okay, so such kind of electron, okay, are responsible for the current. Okay, now in case of conductor, okay, if I have a conductor, metal conductor, okay, so in this metal conductor, what happens? There will be many atoms, right?
Hmm.
Okay, so in this many atoms, what happens? There are free electrons for each nucleus, correct? And these free electrons are free to move. Okay,
Yeah.
and those free electrons are responsible for the current in a conductor in case of metal. But see, if I have a electrolyte, okay, you know what is electrolyte, right? Electrolysis.
Yeah.
So in electrolysis there will be two terminal, two this, correct, anode and cathode, and there will be something called as electrolyte, what solution you put inside. Okay, so in this solution both positive and negative charges are responsible for the current, correct. So see here, positive charges also contribute for the current and negative charges also contribute for the current. So see, if I take electrolyte example, NaCl. Okay, so NaCl, what I can do is Na plus and Cl minus, these two are the ions, correct. These two ions
Yeah.
come together and form this. So when you dissolve it in the water, okay, if you form an electrolyte, what happens, there are Na plus molecules and Cl minus molecules. So these molecules are free to move. Okay, so now what happens is, see, since this is a positive electrode and negative ions will try to attract here. Okay, so now the current is formed by negative ion. Now see this positive, it will try to go to negative terminal, correct. So this positive goes, positive ion produces the current. So here in electrolyte both positive and negative charges are responsible for the current. So see, in this chapter we are restricting ourselves for solid conductors only. Okay, we are
Okay.
interested in conductors, solid conductors. Okay, we are not studying about electrolyte, so in this chapter. Okay, so do you have any doubt, like till now what I thought?
No, sir.
No, right? Okay, so now the question arises, what initiates the current? What initiates the current? So what is the response, what is the reason for current? Who initiates it? Correct.
A charge that is
Yeah,
a
moving.
charged electron.
A charge.
Electron.
Yeah, a charged electron. Okay, electron will have the charge. There's no such thing like charged electron. Electron is always negative charge. Yeah. Now see,
Yeah.
if the electron or the any charge, if it moves, then only the current will be produced, right? If it doesn't move, then no current, correct. So see, if I want to make a charge move, what I have to do, I have to introduce the charge in electric field, correct. So I have to
Hmm.
introduce a charge in some external electric field. So what happens is, when I introduce a charge in external field, what happens, the charge experiences the force. And in first chapter you have studied it in charges and fields. The charge, the force experienced by charge in external field is F is equal to QE, correct. It will experience this amount of charge, correct.
Hmm.
So you got this right in
Yeah.
yeah. So now what happens is, if I introduce this, assume this is my external field. Okay, so in, assume that I have introduced a charge q within this field. So now what happens, this charge will experience a force, correct, and it will move like this.
Yeah.
Okay, so see, now we got our answer. What initiates the current? External electric field. The charge which is situated in external electric field will initiate a current, correct.
Hmm.
Okay, so now see, let's study more deeply about this. Okay, now in a conductor, how does it work? Okay, so imagine, okay, let's take a case where I am not applying external electric field. Okay, my external electric field is 0. Imagine this case. Now what happens,
Hmm.
so this will have some free electrons, right?
Yeah.
Okay, and these free electrons are free to move. Okay, it will move in the random direction. So you can imagine like this, you have a closed room and you have many people inside it. Okay, many people inside it, and all people are running in random direction. Okay, same happens with these electrons. So these electrons are not guided. Okay, those are unguided, so they try to move. Okay, in random direction. So what is the reason that electrons are traveling in the random direction? It is due to thermal energy.
Okay.
Okay, so see, those electrons will have some thermal energy. Okay, it's due to heat. Okay, due to that heat, what happens? The molecule vibrates, and what happens? It since there is a free electron, it will have a sufficient energy, and it will try to move in the random direction. But see, one thing you have to remember is it never leaves the material. Okay, what happens with it happens within the material. Okay, so due to this
Yeah.
random movement, what happens? This electron will collide. Okay, it will collide to neighboring atoms, it will collide to some nucleus, it will collide to some electrons. There will be collision. Okay, and see what you can, if you observe the velocity of it. Okay, so if you observe the velocity of this electron, so what you can do is the average average velocity of all these electron. Okay, if you go on adding those electrons, what was found was the average velocity of each electron. Okay, average velocity of electrons in that material is found to be 0. Okay, so it's like, even though all are moving randomly, okay, overall what happens is that it's like net charge is not moving. Okay,
Hmm.
somehow it collides and comes back to its original position. There is no significant movement. Okay, so net flow of electron is 0. So that's why if you touch a conductor, so if you touch a metal piece, okay, you don't uh, you don't feel any shock.
Hmm.
Correct. So you don't feel any shock, no current. Correct. So that is the reason behind it. So average velocity of each electron is 0. So overall electron is 0. Okay. So now what happens is, imagine if I am introducing a external electric field. Okay. So if I am introducing a external electric field, E is not equal to 0.
Yeah.
Okay, so you can imagine the same situation in like this. Okay, so there are many people in this room. There's many people in this room. Okay, and the situation is same, they are running in random direction. Okay, so imagine somebody came and kept 10,000 rupees in this room. Okay, cash,
Hmm.
and they said whoever finds this first can keep that money to themselves. Okay, now what happens? Already people are running in random direction. Okay, but see, this time what happens? They have some greed, right? Overall they are running in random direction, but see, they try to come towards this money wherever the money has kept, right? So
Yeah.
same happens with the this also, electrons also. Due to thermal motion, there are random motion of this electron. But see, whenever you have external electric field introduced, what happens is these electrons, the net electrons, will try to go in one direction. So see, you know this logic, right? So if this is my direction of electric field, in what direction the electron will move? Is it towards the field or against the field?
Towards the field.
No. So see, electrons will always try to flow against the field. Okay, remember this. So if you have positive charge, okay, this positive charge will flow towards the field, like, see, like this, in the direction of the field. But when you have electron, it will try to flow against the field.
Okay.
Okay, so if my field is flowing left to right, okay, my electron will try to move right to left. Okay, so in this case,
Hmm.
see, this is my electric field direction. My electrons will try to move in this way. Yeah. So
Yeah.
you understood this concept, right?
Hmm.
Yeah. So what we can conclude is, see, if there are external electric field, so net flow or net velocity of the electron, you cannot consider, or average velocity of the electron, you cannot consider it to be 0. Okay, there are some significant movement of the charges, and it will result in some current. Understood. So now see,
Yeah.
now the question arises, in that room, who kept, who kept 10,000 rupees, or else who who was the reason for electric field to be generated? Okay, this question arises, right? what
Hmm.
what is the reason that electric field was generated? The answer is simple: battery was the reason. Okay, so if you connect any this your conductor across a battery, what happens is the electric field is introduced within the material. Okay,
Yeah.
so now what happens is, so like this, if you have a material, okay, if I'm connecting it to a battery like this is my positive, this is my negative terminal. So now what happens is there will be some electric field, direction will be in this way. So you know the direction of electric field, right? How to do it? So direction of electric field is, if you have a positive charge, it is away from the charge, correct? And if you have
Yeah.
negative charge, it is towards the charge. So same logic applies here. So from positive to negative. So what will be the direction of flow of electron? It will be against the field, right? So it
Yeah.
will
So
move in
towards
this
the
way.
positive.
Yeah.
Yeah.
So you understood this concept, right?
Hmm.
Okay. So yeah, for today this much is enough, I think. So it's a demo class, right? So see,
Yes.
if I get a chance, or if you are continuing, so next topic what we'll be discussing is Ohm's law. Okay. So
Okay.
this Ohm's law is a special law which relates the potential with the current. Okay, this potential difference with the current. Okay. So do you have any doubts?
No, sir.
Yeah, yeah, ask me.
I don't have any doubts. I
No doubt.
understood the concept.
You understood, right? Okay. So if you have any doubts, don't hesitate. Okay, just interrupt me with between the classes and ask your doubt. Okay. Yeah,
Yes, sir.
yeah. You can leave the class.
Thank you, sir.
Yeah, welcome.